Now, this topic is about the general piping and valves para sa lahat to. So, meron tayong identification colors for pipe, identification of piping by color or color bands at convenient location shall be as follows. In addition to color coding, the specific contents of piping must be identified by sticker, stencil, tag, etc. That is one. Arrow. Color band and pipe flow identification shall be as specified and installed as shown. Pipe flow identification is yung arrow. Tapos color band. Andito yung mga colors. So water is green, steam. Naman sa plumbing nakita niyo blue. Pero sa industrial type, sa mechanical, sa ngayon, ginagamit na is yung green. Steam, silver gray. Oil, mineral, vegetable, or animal, flammable or combustible, is brown. Gases in either gaseous or liquid vapor, and pneumatic conveyed fumes. And material is yellow ochre. Para siyang orange, PG. Acid alkali, violet. Air, light blue. Other fluids, including drainage pipe, unless the drain is to a particular service, is black. Firefighting materials, including detection and suppression system, is safety red. Hazardous services, generally with other identification of content, safety yellow. Electricity is light orange. Ito yung mga orange na conduit. Communications is white. Kung makikita nyo yan sa mga building, ayan ang mga identification. So, normally, sa ibang piping meron information. So, ito naman is yung pipe flow identification. So, flow diagram, ito yung dimension niya, 330 for pipes 150 mm and over, including insulation with fuse meaning insulated. Ito ganun din, under 150 mm. 38 is 300 mm ito. Manipis yun na width. Kasi i-didikit niya yan dun sa pipe. So notes, one arrow shall be of stencil type. Arrow shall be same color as pipe banding. Arrow shall be readable from floor. Arrow shall be installed every 456 meter, mm. So pipe flow identification notes, all arrows shall be painted on pipes. Stick on or glued on arrows will not be acceptable. Dapat naka-stencil. Hindi lang basta ididikit. Or painted. Stick on yung mga dikit-dikit lang nila. Dito kasi yung tatanggal yun. So, flow velocities sa piping. So, meron ulit tayo dito. In practice, the average fluid flow velocities may be as follows. For water, normally it is 1.5 to 3 meters per second. High pressure saturated steam is 25 to 50 meters per second. Yung naman natin discuss natin fast na. High pressure saturated steam is 50 to 77 meters per second. Atmospheric exhaust steam is 40 to 60 meters per second. Low pressure exhaust steam is 100 to 120 meters per second. Yung average flow velocity based on inside diameter. Now, start for the power piping and design. Dalawa kasi ito, meron sa refrigeration, di ba? So, unahin natin yung power piping. Ano yung gas saka sa refrigeration. So, power piping system includes all steam, water, and oil piping in the component parts such as the pipe, flanges, porting, gasket, valves, and fittings for industrial steam generating plant, central heating plant, and industrial plant. So, yung sa dole, may nakalagay doon power piping application. Ganun sila. I-apply mo yan. So bulbs, all bulbs in normal nominal sizes. So 80 mm equivalent to 3 inches and smaller for pressure above 174 kilopascal or 250 psi gauge, but not above 275 kilopascal or 400 psi gauge. 50 mm, 2 inches smaller for pressure above 275 ito or 400 psi gauge, not above 4137 kilopascal or 600 psi gauge. And 40 mm, 1 and 1 half inch and smaller for pressure above 4137 kilopascal, 600 psi gauge may have screwed flange or welding ends. Yan, pwede mo siya i-weld. Wait, napata natin to. So ito yung rules sa valves. For all valves larger than sizes specified in the preceding paragraph, dito, more than that, flange or welding ends shall be used. So hindi pwede yung screw. So pa makikita niyo yung mga flange of valves. So rule niya. Pag 80 mm or 3 inches below, pressure niya naman is 250 psi gauge. Tapos hindi above ng 400. So pwede ka mag-screw. So wall thickness. So the following formula shall be used to determine the pipe wall thickness. So P sub M is equal to PD over 2S plus YP plus C. So P sub M is the minimum pipe wall thickness in millimeter. P is the maximum internal surface pressure in kilopascal. T is the nominal pipe wall thickness in mm. So later, wala yung equation, diba? D is the outside diameter of pipe in millimeter outside. S is the allowable stress in materials in kilopascal. So may table tayo dyan. C is the allowance for trading mechanical strength of corrosion in millimeters. Sa table 11.6.4a ng PSA Code 2008 or 2003. Y is the coefficient for values. Table 11.6.4b. So ito. Since all pipe furnished by the mill is subject to 12.5% variation in wall thickness, the thickness P sub M should be multiplied by 8/7 to obtain the nominal wall thickness. Yung pinakamalapit sa tape na wall thickness nominal, yun gagamitin. Dahil compute mo dito, mamultiply mo kasi ng 8/7 para makuha mo yung nominal wall thickness. So ito yung Y values. For the type of steel, mayroong ferritic, austenitic. Take note, austenitic steel, ito yung stainless sample. Ferritic, ito yung mga iron, steel, yan. So, 900 Fahrenheit and below, ito yung Y mo, 0.4.46 na rin, and 50.5.7. So, check nyo yung temperature. Diba? So, para makuha nyo yung Y. So, pag ginamit mo to 0.5 pero 1,000 ka na, so mali na. Sa table 11.6.4, ano yung values of C in inches and current station mm. So this is 3.556 na. This is 4.527 mm. So for cast iron, centrifugal cast 0.40. Cast iron pump only is 0.80. So threaded steel, wrought iron, or non-ferrous pipe, ito yung 3/8 inch and smaller is 0.05. 1/2 inch and larger is equal to the depth of the thread in millimeters, etc. So for ito pala, plain and steel or wrought iron. So 5 or tube for 1 inch, ito gamitin mo. Smaller. For above 1 inch, 0.065. Common to. Plain and non-ferrous pipe, mga plastic, that is 0. So either pressure or temperature of both may exceed the nominal design values if the computed stress in the pipe wall calculated for the pressure does not exceed the allowable stress in table 11.6.5 or 11.6.58 or expected temperature by more than the following allowances for the duration of the for the period of duration indicated. So ito yung allowable stress in 5 for power 5 feet. Take note ulit, hindi ko kasi baguhin na to. Kasi ito sa PSM method to eh. So this is yung materials. For example, welded materials form is welded for carbon steel. So ang lap welded mo, ang specification is K124. So hanapin mo dito kung lap welded siya. Ang stress mo is negative 20 to 100 Fahrenheit. So ito yung ano mo. Okay. So from 200 to kung nag-200 ka na, above na dito, so 200, 60, 50. Ayan, pababa na pababa. Okay. And you can interpolate from 100 to 200, tapos 200 to 300, mag-interpolate. So based on temperature, so tapos yung materials mo. Ayan. Okay. Ito na isa-isa ito. So up to 15A, up to 15% increase above the S value during 10% of the period operating period. Kung alam yung operating period. So up to 20% increase above the S value during 1% of the operating period. Ito yung allowance niya. Sabi na ulit. Either pressure or temperature or both may exceed the nominal design values. Yun. For the if the computed stress in the pipe wall calculated for the pressure does not exceed the allowable stress or the expected temperature by more than the following allowances for the period of duration indicated. So design ka lang sa dito, limit mo to. Kung ina-allow mo yung increase, so at 10%, so meron kang 10% increase sa value mo to. So sa atin sa ngayon, huwag muna tayong previous dito. Magdagal 15%, 20%, base muna tayo sa design value. So hindi pa dapat yung magtara. Ay, hindi. Ay, sumaba ng konti, okay na. So balik-balik kayo sa application. Practice. So ito naman, yung mga table. So ito. Allowable stresses for pipes in power piping. Ito pa yung ibang table, ibang materials. So ito, sinasabi ko, this is 22 650 yan, 650. Ulitin ko. Hindi ko kasi babagoyin yan kasi nasa plug yan. Okay, properties ng book yun. So this is the 20 to 650, 700, 750, 80, 850, 90. Diba? Common sense. Alam mo yun naman, bakit 22 to 650 tapos 70, 750. So, hindi pwede, di ba? This is 650. So, ito pa. Yan lahat. Ito naman lang yung ano niya, yung materials, specification, anong grade, tapos makikita mo yung ultimate niya. Makikita mo dito yung value ng S, design stress. Diba? So pag wala dyan, so hindi applicable. O ito na talaga, hindi siya applicable. Okay. Ito naman yung properties of pipe. Sabihin, yung table. So, nominal pipe in inches, 1.8, 1.4, 1.5. Schedule number 40x. Diba? So, outside diameter, inside diameter, wall thickness, weight of pipe, weight of water in pipe. Outside surface, inside surface, transverse area, yung cross-sectional area. So, nung pipe tube. Pipe wall. Now, for the pressure reducing valve, the relief or safety valve shall be located adjoining as close as possible to the pressure reducing valve. It is mandatory that a pressure gauge is installed on the low side of reducing valve kasi yun ang target point mo. So, now for the pipe, so for pressure above 4,137 kilopascal or 600 psi gauge, the pipe shall be, yan, ito mga dapat na pipe dyan. Seamless steel meeting ASTM specification A106, A312, A335, or A376, or 2 forged and bored steel meeting A369, or 3 automatic welded steel meeting A312, or 4 electric fusion welded steel meeting with ASTM specification A-155. Ito yung applicable dito. So, pipili ka ng isa dyan para mag-design dito sa ito muna ang gagamitin. Pag selection of materials, marami yan. Letter B, for pressure above 172 per kilopascal, 250 psi gauge, but not above 4137 kilopascal or 600 psi gauge, pipe shall be 1. Electric fusion welded steel of ASTM specification A134 or A139. Number 2, electric resistance welded steel pipe of ASTM specification A135. Number 3, forged or bored steel meeting A380, or 4, automatic welded steel meeting A312. Number 5, electric fusion welded steel pipe meeting with ASTM specification A-155. 6, seamless steel in accordance with the ASTM specification A-106. 7, seamless or electric resistance welded steel pipe of ASTM specification of A53. So, mga BI pipe, makikita nyo may nakalagay A53 or A56. For service up to 400C, kasi may temperature na to, dito wala pa, and pressure of not over 250 psi gauge, any of the following classes of pipe may be used. 1. The electric fusion welded steel of ASTM specification A-134 or A135. Number 3, wrought iron pipe of ASTM specification A72. Letter D, grade A seamless steel pipe of ASTM specification A106, wrought iron pipe of ASTM A72, grade A seamless steel pipe of ASTM A53, or grade A is electric welded pipe of ASTM A53, A135, or A139 shall be used for close coiling, cold bending, or other uses. Yan yung mga bend. Patigas yan. Now, for the bolting, mga types of bolts. For steam pressure service, for steam service pressure in excess of 172 per kilopascal or 250 psi gauge, or for steam or water service temperature exceeding 232 C or 450 Fahrenheit, the bolting material shall conform to ASTM specification A193. For temperature exceeding 400 C, 750 Fahrenheit, only bolt studs are recommended. When cast iron flanges are used, bolting material shall be or carbon steel conforming to ASTM specification A-307 grade B or A-107 grade 1120. Now, the flange bolts or bolt studs shall be of the dimension and material specified for the purpose in the corresponding American cast standard. Bolts or bolt studs shall extend completely through the nuts, and if desired, may have reduced shock of a diameter not less than the diameter of the root of the threads. Nuts shall conform to ASTM specification A194. full description, hanapin nyo yung step specification ay 194. Net. Meron yan. Haba yan. So, flanges naman. Flanges are conformed to American Standard B16.5 for respective pressure and temperature or to the specification set by the manufacturer. So, dito, meron itong size, 5 size, meron siyang katapat na flange size or dimension, under yung width, ilang butas, bolt, diba? Outside diameter, so nakita mo dito. Depende sa pressure. A, 1724 kilopascal, 250 psi gauge, and plus 862 kilopascal or 125 psi gauge. Cast iron integral or screwed companion flanges may be used with a full face gasket or with a ring gasket extending to the inner edge of the bolt holes. So, search nyo yung mga types ng gasket. Dito, yung power plant engineering ni Walsh, SI metric MTS yun or meter kilogram seconds in units with from English units kinonvert. Check nyo sa library, meron ng English units. Yung mga table of flanges niya, kinonvert niya yung pouch na, hindi yung PSI. Kaya may mga error dun sa MTS version ni power plant ni Walsh. Kaya hindi ko pinapagamit sa inyo yung mga equation doon. Ito yung Boiler's power na heated surface. So, mali yung conversion niya ng yung point na yung 0.91 square meter per Boiler's power. That is 10 square foot. So, magiging 0.93. Diba? Check nyo na lang. Pag may magamit ng formula, check nyo yung sa more. Ano mali doon. Tapos yung horsepower niya is metric horsepower. Hindi siya 0.746. Kilowatt per 0.735. Kaya hindi ko yung pag-gamit. So B, when bolting together, 2 plus 1724 kilopascal to 50 PSI integral or screwed companion cast iron flanges having 1.6 mm or 1/16 inch raised faces. The bolting shall be of carbon steel equivalent to ASTM A-307 grade B. C, 1034 kilopascal or 150 PSI gauge steel flanges may be bolted to cast iron valve, fittings, or other parts having either integral plus 862 kilopascal or 125 PSI gauge cast iron flanges or screwed class 862 kilopascal or 125 PSI gauge companion flanges. Ito na yung pinaka-liit na pressure ng flange. 125 or 150. Napansin nyo, pag cast iron, 125. Sa steel, 150. Okay, parang same lang yan. 2269 kilopascal, 300 PSI gauge steel flanges may be bolted to cast iron valves, fittings, or other parts having integral plus 1724 kilopascal, 250 PSI gauge cast iron flanges or screwed plus 1724 kilopascal or 250 PSI gauge cast iron companion flanges without any changes in the raised face or other flanges. So, ito naman magkatapat. 300 PSI gauge sa steel flanges and 250 PSI gauge sa cast iron flanges. Fittings. Ano yung mga fittings? Yung mga elbow. D. All fittings in nominal size above, say, 2 FTM for pressure above 1724 kilopascal. So, 250 PSI gauge. Yung 80 mm inches, but not above 2758 kilopascal. 400 PSI gauge. And 50 mm for pressures above 2758 400 PSI gauge, but not above 4137 kilopascal or 600 PSI gauge, and 40 mm for pressure above 4137 kilopascal or 600 PSI gauge, but not above 17238 kilopascal or 2500 PSI gauge shall have flange end or welding end. So, hindi pwede yung screw. For the gasket. Gaskets were required. shall be of material that resists attack by the fluid carried in the pipeline, shall be strong enough to hold the pressure, and perform the purpose intended throughout the temperature range encountered. Gasket shall be as thin as the finish of the surface that will permit to reduce possibility of blowing out. So mga gasket is paper, vegetable fiber, rubber, or rubber-insulated gaskets cannot be used for temperature in excess of 121 C to 50 Fahrenheit. So topics in gasket design, wala sa atin yun. Pag nagtrabaho na kayo, search nyo na lang gasket design kasi merong mga gasket constant yan. So hangers, supports, and anchors. So ito rin mga additional ito, pag-aaralan nyo. Nagtrabaho na kayo mga hangers, supports, and anchors. Structural lang to. Para ganito nyo yung mechanics nyo dito. Hangers, supports, and anchors shall be made of durable materials in tunnels in buildings of permanent fireproof construction. Piping may be supported on or hung from wood structure if all piping used for conveying fluid at a temperature above 121 C or 250 Fahrenheit is spaced or insulated from such wooden members to prevent dangerous heating. The hangers and supports shall permit pre-expansion and contraction of the piping between anchors. All piping shall be carried out on adjustable hanger, properly labeled support, and suitable sway bracing, vibration dampeners, and etc. shall be provided when necessary. Ito dapat sa building design nyo yung talagang topic ito. Hanger, support, and anchors. So pipe sleeve. Where pipes are installed in a concrete core or other building member, it shall be protected for the entire buried length with a suitable protecting pipe sleeve of steel, cast iron, wrought iron, or tile. Ito talaga ang dapat. Dapat sinabing dapat. Kasi marami pa dito nagkakabit, sinasalaksak lang yung tubo. So, okay. Walang sleeve. But exception may be taken to the preceding rules where pipe pass through walls, floors, partition, etc. that must be kept watertight. So drains, drip, and steam traps. Yan. Kasi nasa power piping tayo, kailangan yan steam. Suitable drains or drip shall be provided wherever necessary to drain the condensate from all sections of the piping and equipment whenever it may collect. Suitable drains shall also be provided to empty water lines, water storage tank, equipment containing water, etc. when such piping and equipment is out of service. At least one valve shall be placed in each drip or drain valve. Yeah. Drip lines from steam headers, mains, separators, and other equipment shall be properly drained by traps installed in accessible locations and below the level of apparatus drain. Drip pumps, preferably with orifice control, may be used in lieu of trap if they are safely installed, protected, and operated under regular supervision. Hindi naman, mag-trap ka na lang. All drains line shall have drip valves for free flow to the atmosphere. So this is the power piping. Example, letter na. Next type is the industrial gas and air piping system. They are gases. This is industrial air and gas in mines, power plant, industrial and gas manufacturing plant. So A, piping with metal temperature above 232 C or 450 Fahrenheit or below negative 2.9 C, 27 Fahrenheit. A, air piping system operating at a pressure of 207 kilopascal or 30 psi gauge or less. Ayan mga application. C, piping lines with pipe bricks or other refractory material used for conveying hot gases. And the minimum thickness of pipe wall required shall be determined by the following formula for the designated pressure and for temperature not exceeding 232 C. So 450. Note yan ha. The P sub M is equal to PD over 2S plus 0.8 P. So meron siyang 0.8 dito plus C. Where P is the maximum allowable permissible operating pressure in kilopascal. So, kahit ang SI pwede rin dito. Basta ang constant mo, tama sa units, same units ng PMs. Now, the value obtained may be rounded to next higher units of 10. So, yung pressure. The maximum allowable operating pressure computed when S values permitted under this paragraph shall not exceed 2/3 of the mill test pressure for a service temperature of 38 C, 100 Fahrenheit, or less than 5/9 of the mill test pressure for a service temperature of 232 C, so 450 Fahrenheit. So, ito yung value niya. S is the maximum allowable hoop stress in kilopascal. So, ito yung table 11.7.2. So, andito yung mga materials, specifications. Andito naman yung maximum allowable stress in PSI gauge. So, yan. Ano ko yan? Temperature. Calculate ka na lang dyan. Ito yung value mo. This is for gas and air piping. Kanina is steam. So for steel or wrought iron pipes, except not welded manufactured under a specification not listed in table 11.7.2, the value of S shall be 0.6 K for a service temperature of 38 C or less, or 0.52 K for a service temperature of 32 C, where K is the stipulated minimum effective yield strength calculated in the manual described in section 7.3. And T sub M is the minimum pipe wall thickness in millimeter, that is nominal wall thickness less the manufacturing tolerance for the wall thickness. Where available from on hand or in stock, the actual measured wall thickness may be used to calculate the maximum allowable operating pressure. Nasa kami muna, nasa stock. Pero kung wala, so maglalagay ka ng dalawa. C, corrosion in millimeters obtained from the following. So ito yung type of pipe and the value of C in inches. Ito. Tapos, ito naman yung 0.05 inch. Yan, 1.7 mm yung equivalent sa millimeter. D is the outside diameter of the pipe in inches. Millimeter. And the effective yield strength K of steel or wrought iron pipe may be determined by taking the product of Y, the stipulated minimum yield strength, and E, efficiency of the longitudinal joint. The value of E shall be taken from the following. So ito. Specification number, type of pipe, and the factor. Efficiency yan. So ito yung sa industrial gas and air piping equation. Next, sa Word version nitong check na lang doon, medyo mahabang discussion. Definition of terms pa. Dito ko sila ba dito dahil diba, pag sa face-to-face pusang oras nito, pinakapos oras kasi yung isang dito. Kasi yung dati, una, may laboratory pa itong IPE. Maraming 3 units pa yata. Ngayon na yung 2 units. So refrigeration piping system naman tayo. Refrigeration piping shall be understood to comprise all refrigerant and brine piping. malamig. Were never used and were erected on the premise of factory assembled. Piping system for refrigerant shall be designed for not less than pressure given in table 11.8.2.1. Eyesight, outside. The minimum thickness of the pipe coil required shall be determined by the following formula. T sub m is equal to PD over 2S plus 0.8 plus C. So Tm is the minimum pipe coil thickness in millimeter. P is the maximum internal surface pressure in kilopascal plus allowance for temperature up provided at 11.8.2.4 or 7.2 D. Check nyo lang sa PC method ko. And water hammer allowance for cast iron pipe up as provided in section 11.8.2.3. So yung P. Yung S, the value of P shall not be taken at less than 689.5 kilopascal or 100 PSI gauge for any condition of service or material. So use always 100 PSI gauge. T is outside the diameter of the pipe in millimeter. S is the allowable stress in material due to internal pressure, table 11.8.3. So the same ang dito yung value niya. C, allowance for trading mechanical strength and or corrosion in millimeter of plane from the following list. The type of pipe, ito naman yung value of C. Diba? Millimeters tapos inch. So in case of cast iron pipe, the minimum values of water hammer allowance to be added to P are given in table 8.6.3. So ito yung mga actual equation nyo. Checkin nyo ng value. If P is equal to ganito. So pagka mo ng P, so internal pressure plus ito, yung nag-gamit ito doon. Okay. So na-compute ng internal pressure plus ito, yung nag-gamit ito doon sa pagbuo ng thickness. Ang ibig sabihin niya. So wala muna tayo nito. So gate valves. So punta tayo sa mga valves. So gate valves, una, common. Gate valves are linear motion valve having a closure element perpendicular to the process. Tingnan niyo yung picture. Flow that slides into main stream to provide shut-off. These are used in low pressure systems. The problem with this valve is that they cannot handle throttling operation, are easily fouled, and cannot be used in system having high pressure drop. It is difficult to obtain tight shut-off with this valve, and they take longer to open or close than any other manual valve. The different types of gate valves are parallel gate valve snipe, parallel gate valves, knife edge gate valve, and through conduit gate valve. So ito yung pass ng gate valve. Body, disc, bonnet, stopping box, packing, gland, packing nuts, stem, well, and well nut. So important dyan is yung materials. Yun sa application mo. Next type is the butterfly valve. These valves are mainly used as on-off valve. Pamalakihan to. Mainly a rotary motion valve that uses a rotating round disc as regulating element. There are two types of butterfly valves, concentric and eccentric butterfly valve. These valves can be directly installed in between two flanges without any special end connection owing to their very narrow face-to-face dimension. It has a large flow coefficient, and due to rotary motion of the shaft, deflection forces generated are far less than a linear motion valve. They have a high pressure recovery factor. These valves are used in low pressure application. Cavitation and choke flow can occur easily with this valve when installed in an application with high pressure drop. Next is the plug, cocks, and ball valves. Kita niyan, pero maliit yan ang mga ball valve. For temperatures below 250 C, metallic plug cock are useful in chemical process line, as in laboratory stopcock. A quarter ton of steam takes the valve from fully open to fully closed. And when fully open, the channel through the plug may be as large as the inside of the pipe itself, and the pressure is minimal. In a ball valve, the sealing element is spherical, and the problems of alignment and creasing of the element are less than with plug cock. In both plug cocks and ball valves, the area of contact between moving element and the seal is large, and both can therefore be used in throttling service. Ball valve find occasional application in flow control. Non-return check valve. So ito, isang type is the swing type check valve. So non-return valve allowed the fluid to flow only in the desired direction. The design is such that any flow or pressure in the opposite direction is mechanically restricted from occurring. All check valves are non-return valves. Non-return valves are used to prevent backflow of fluids, which could damage equipment or upset the process. Such valves are especially useful in protecting a pump in a liquid application or compressed gas application from backflow when pump or compressor is shut down. Non-return valves are also used in process systems that have varying pressure, which must be kept separate. So yung valve when closed and when open. There are two types of the check return valves, the swing type and the spring type. Ito yung swing and yung common. And the swing type, the pressure of water forces the valve gate to swing open. But once the flow stops, gravity causes the gate to fall closed, preventing a reversal of flow. This type of valve must be mounted vertically or horizontally to work properly. In contrast, the gate in a spring check valve is spring-loaded. Water pressure forces the gate open just as in the swing type, but when the flow stops, this spring, not gravity, forces the gate closed. This enables the valve to be mounted in any position at any angle. Next is the globe valve. A globe valve is a parts. A globe valve is a linear motion valve characterized by a globe-style body with a long face-to-face dimension that accommodates smooth, rounded flow passages sufficiently long enough to ensure smooth flow through the valve without any sharp turns. This valve can be used in both gas as well as liquid application and can handle severe conditions of temperature and pressure. The majority of the globe valves have a top entry design, thus permitting easier servicing of the internal parts and allowing the valves to remain in line with maintenance needs. But these valves have certain disadvantages also. They have a high cost and a large size factor and cannot be used for unclean liquids. They are mainly used for flow control and in cases including vacuum or high temperature steam. Solenoid valve. Solenoid valve are best suited for small, short stroke on-off operation requiring very high speed of response. This response can open or close in 8 to 10 8 to 12 milliseconds. However, they are limited to pressure drop below 20.7 bars, although when pivoted with pilot feeder or double seat, they can handle higher pressure drop. A solenoid valve contains a valve body, a magnetic core attached to the stem and crest, and a solenoid coil. A small spring assists the release and initial closing of the valve. The valve is electrically energized to open. When an electrical signal is input to a solenoid valve, magnetic change over valve, the drawing force of the move, solenoid moves this spool, changing the direction of flow. For the material of construction of valve, So the selection of the valve body material is usually based on pressure, temperature, corrosive properties, and erosive properties of the flow media. Also, the choice of the material depends on economic factors. Majority of control valve involves non-corrosive fluid at reasonable temperature and pressure. Therefore, cast iron and cast carbon steel are most commonly used valve body material. Type schedule. So, ito na. The purpose of type schedule standard is for all industries that use pipe to use the same standard. Type schedule are a means of categorizing pipe and identifying strength and characteristics of its capabilities. For all pipe sizes and outside diameter, OD relatively remains constant. Parehas. Meron siyang 10 inches and above. The variation in wall thicknesses affects only the diameter. Pipe schedule is an American definition to define pipe thicknesses and how pressure can pipe stand. The most commonly used schedules today are 40, 80, and 160. There is a commonly held belief that the schedule number is an indicator of the service pressure that the pipe can take. So the iron pipe size IPS is an older system still used by some manufacturers and legacy drawings and equipment. The IPC number is the same as IPS, but the schedules are limited to standard wall, STD, extra strong XS, and double extra strong FSS. STD is identical to Schedule 40 for NPS 182 and NPS 10 pipe size, nominal pipe size, NPS, inclusive, and indicates 0.375 inch wall thickness for NPS 12 and larger. SX is identical to Schedule 80 for NPS 182 NPS 8 inclusive and indicates 0.5 wall thickness for NPS 8 and larger. Different definition exists for XXS, but it is generally thicker than Schedule 160. Industrial pipe thickness follow a set of formula expressed as the schedule number, as established by the American Standard Association, now reorganized as ANI, the American National Standard Institute, and ANSI. 11 schedule numbers are available for use. 5, 10, 20, 30, 40, 60, 80, 100, 120, 140, 160. The power plant demolish or pattern sa likod nun ang kompleto to. So, a schedule number indicates the approximate value of schedule number is 1000 P over S, where P is the service pressure, S is the allowable stress, PSI or in units. The higher the schedule number is, the thicker the pipe is. Since the actual diameter of its pipe size is standardized, a particular nominal pipe size will have different inside pipe diameter depending on the schedule specified. For welded and seamless float steel pipe, to distinguish different weight of pipe, it is common to use schedule terminology from ANSI ASME D36.10, welded and seamless wrought iron pipe, metal light wall, Schedule 10, Schedule 20, Schedule 30, Schedule 40 in standard weight. Schedule 60, extra strong, Schedule 80, 100, 120, 140, 160, and double extra strong. Note that many of these schedules are identical in certain sizes. For stainless pipe, meron tayong for extended pipes to 12 inches, schedule numbers from Schedule 5S to Schedule 80 and 80S are used as published in ANSI ASME 36.19M stainless steel pipe. Yung may S, stainless yan. Schedule 5S, Schedule 10S, Schedule 40S, Schedule 80S. Oh. So, yan yung discussion sa steel pipe. Now, for the copper and tubes, meron tayong mga copper, type of copper. Meron type L. Type L copper pipe in tube has a thicker wall than type M and GW pipes, making it
preferred choice for longevity. There are two kinds of type L, merong hard and soft temper. Type L will be marked with blue along the pipe or tubing. So, bumalik ng example. Hard temper type L plumbing applications include merong above ground water distribution, above and below drainage and venting system, building sewer, kung gumagamit ng capital sa plumbing. Soft temper type L plumbing applications include water service pipe, water distribution above and below ground. And type M copper pipe. Type M copper pipe in cubic is commonly used in recipients of plumbing because it was a thin wall and can be produced with and sold at much lower cost. For water distribution, longevity type M is not recommended. Type M copper is also better for heating application because of the thin wall thickness. Type M is identified with red marking along the side. Hard temper type M plumbing applications include above ground water distribution, above ground drainage system. For the soft temper type M shall not be used in plumbing system. Type K, copper pipe. Type K copper pipe in tube is the most robust of the four types. Yan yung makapal. Comes in hard and soft temper and will be identified by green marking. Type K can be used for many other applications such as fuel, gases, HVAC, fire protection system, and vacuum system to name a few. So hard temper type K plumbing applications include above ground water distribution, above and below ground drainage and venting system, building sewer. For soft copper type K applications include water service pipe, water distribution above and below ground. Meron naman tayong DWB copper pipe. So DWB copper pipe is used for drainage, waste, and bed. Above ground only. It is identified by yellow marking. So punta tayo sa mga sample. So ito na. Wood sample problem number 1. Wood schedule 120 885 made to 853-SA specification be acceptable on a line operating at 250 PSI gauge 750 Fahrenheit. The given 8 inches schedule 120 250 PSI gauge 750 Fahrenheit A5 PSA. Required check of schedule 120 if acceptable. Solution. So, for schedule 120, power factor designed by PE, pattern, 8 inches diameter, ang nominal voltage sa likod nito, tignan na ng pattern. 0.718 is. Checkin natin kung kaya. So, table 11.6.5 at 750 Fahrenheit. E5T is the specification. S is 9,100 PSI at 750 Fahrenheit grade A. Check ko doon. Sa question method o yung lecture natin dito table 11.6.5. 750 so 9 months. So, T sub M is equal to PD over 2S plus YP plus C. So, ginamit ko ito. Kinuha ko ito sa March. Yung solution niya, since lecture to, ginamit ko yun sa PS method. Where P is 250 PSI, P is 8.625, not sa diameter to, S 9,100. C is equal to table 11.6.4A is 0.065, plain and steel. Y is equal to table 11.6.4B is 0.4. Already. The T sub M is equal to 250 times 8.625 over 2 times 9,100 plus 0.4 times 250 plus 0.065. Relating to the plain and is 0.180 each. Now, the nominal wall thickness is 0.180 times 8 over 7 multiplier. It's 0.209. Then, schedule number is 1000P over S is equal to 1000 times 250 over 9100 is 27.5. So, Planchuri in design. So ito, use schedule 20. Wall thickness is 0.25. This is the answer. So therefore, schedule 120 is not advisable in terms of economics. Masyadong mahal. Specify ka. Okay? So, specify ng sample ng problem number 2. Specify the pipe required to carry 6,000 pounds per hour steam per hour at 1255 psi gauge, 1,000 Fahrenheit with a velocity approximating 10,000 feet per minute. So given is 10,000, 100,000 pounds steam per hour at 1255 psi gauge, 1,000 Fahrenheit with velocity approximating 10,000 feet per minute. Required, specify the pipe required. So wala kang ibang idea. Velocity lang. Sa velocity, makukompute mo yung pipe. Sa pero yung pipe may velocity. Makukompute mo yung pipe. Tapos makukuha mo yung flow rate. Makukuha mo yung diameter. So, i-check mo yung diameter kung tama. Based, base naman dito sa pressure and temperature. Diba? So, solution at 1255 psi gauge 1,000 Fahrenheit. Specific volume from steam tables is 0.6538 cubic feet per pound. So, yun. Makuha natin dito is inch diameter ng pipe, pero yung schedule number hindi natin pa-identify. Okay? So, ito yung specific volume. So, Q is equal to MB is equal to 600,000 pounds per hour times 0.6538 cubic feet per pound times 1 hour over 60 is 6,538 cubic feet per minute. Thank you. So, determine the diameter na masatisfy itong approximating velocity. The square root of 4Q over 5B is equal to the square root of 4 times 6538 over 5 over 10,000 is 0.9124 feet or 10.949 inches. Use, so decide ka. Seamless steel meeting ASTM specification A1T2 for pressure above 600 psi gauge. I-check nyo doon sa mga previous slide ito. Andun yun, diniscuss ko, di ba? Merong 600 psi gauge. The table 11.6.5 at 1,000 Fahrenheit. Grade TP321. S is equal to 11,500 psi at 1,000 Fahrenheit. So, schedule number is 1,000 P over S equal to 1,000 times 1,255 over 11,500 equals 109.
Now, ang schedule number natin is 109.1. So, pinakamalapit is schedule 120. So, from power plant Turin design by PJ Patter, andun yung 14 inches. Ang IDE is 11.814 inches. Wall thickness is 1.093. So, check for thickness. Ito patapos. So, then, T sub M is equal to PD over 2S plus YP plus C, where P is equal to 1255 PSI, D is 14 inches, S is 11,500 PSI, and C is 0.065, Y is 0.4. Austenitic. Bakit? Seamless steel 8312. As a number 3, that is stainless. Stainless is austenitic, yung engineering materials. So T sub M is equal to 1255 times 14 over 2 over 11,500 plus 0.4 times 1255 plus 0.065 is 0.813 inch. So the nominal wall thickness is 0.813 times 8 over 7 is 0.929 inch. Therefore, use schedule 120, 14 inches, wall thickness 1.093 inch. So, save. Sample number Sample problem number 3. What maximum working pressure is advisable in an 18-inch OD schedule 45 853 SA operations not to exceed 450 Fahrenheit? So given 18 inches OD schedule 40 853 SA 450 Fahrenheit. Required 3. Solution. Table 11.6.5 are 450. So baka may makita kayo 1650, 22, 1650, yun ang kinuha nyo. So hindi. Nalampas ako. That is 650. Okay pa pala. Tama. Below 650. Pasok siya. So S is equal to 10,200 at 450 Fahrenheit, grade A. So table 11.6.5C, 18 inches, schedule 40. The nominal wall thickness is 0.562 inch. So T sub M is equal to 0.562 times 7/8 is equal to 4.92. Diba? Baliktad. Kukunin natin yung thickness na gamitin sa formula. Then T sub M is equal to PD over 2S plus YP plus C, where D is 18 inches, S is 10,200 PSI, and C, table 11.6.4A is 0.065, plain and steel. Y is table 11.6.4B, 0.4 for phonetic. So T sub M is equal to P times 18 over 2 over 10,200 plus 0.4 times P plus 0.065 is 0.492 inch. So for P, so P is equal to 488.57 PSI. So this is now your question answer. The maximum is 488.57 PSI, or if you can set mo sa 488 PSI o 480, pwede kasi maximum ang yung nag-usapan dito. Huwag mo gagawin 490. Lumampas ka. Okay? So this is the end of this general 5P topic.